As we play the game, we start to notice patterns and begin to formulate rules in our minds. For example, suppose we want to move 4 disks from Tower A to Tower C. At some point, we need to move the largest, bottom disk, to the bottom of Tower C. But to do that, Tower A should only have the largest disk on it, and Tower C must be empty. And to reach this state, we need to first move the top 3 disks from Tower A to Tower B. Once we move the largest disk to Tower C, we can complete the game by moving the 3 disks from Tower B to Tower C. Thus, in order to move 4 disks, we first need to move 3 disks. And how do we move 3 disks? At some point, we need to move the largest of the 3 disks into the destination. And that means the smaller 2 disks need to be in a different tower. Thus, we need to first move the 2 smaller disks out of the way, move the largest disk to the destination, then move the 2 smaller disks to the destination. Sound familiar? We can solve the Tower of Hanoi by executing the same procedure many times, decreasing the disk count each time. In other words, we will use a recursive algorithm. Let's precisely describe the solution. First, label the disks with numbers 1 to n, where 1 is the smallest disk and n is the largest disk. Let's represent each tower as a stack, where the elements are the disk numbers. Then we can represent the full game state as a stack of 3 stacks. For example, here is the initial state of Tower of Hanoi with 3 disks. This stack has 3 elements. The first element at index 0 is the stack 1, 2, 3, which represents Tower A with 3 disks. The other 2 towers, at index 1 and 2, are empty. After we move disk 1 to Tower 2, the state is as follows. In the above example, the source tower index is 0 and the destination tower index is 2. The index of the other tower, which is neither the source nor the destination, is 1. As another example, if the source tower index is 1 and the destination tower index is 0, then the other tower index is 2. Here is the problem statement. There are n disks labeled 1 through n. All n disks are currently in tower SRC. Please list the stack operations that move all the disks to tower DST. And here is the solution to the Tower of Hanoi. OTH indicates the index of other tower. Step 1. Move the disks 1 through n-1 from tower SRC to tower OTH. Step 2. Move disk n from tower SRC to tower DST. And step 3. Move the disks 1 through n-1 from tower OTH to tower DST. To move n disks, we first move n-1 disks, and to move n-1 disks, we first move n-2 disks, and so on. When n equals 1, then skip steps 1 and 3 and move disk 1 from SRC to DST. For example, if there are 5 disks, then n equals 5. Initially, SRC is 0, and the DST is 2. OTH, the remaining tower, is 1. Here is an example run with 3 disks. Initially, all 3 disks are in tower 0. We first move the substack 1, 2 from tower 0 to tower 1. Then we move 3 from tower 0 to tower 2. Finally, we move the substack 1, 2 from tower 1 to tower 2. We can click the caret to expand the steps. For example, to move the stack 1, 2 from tower 0 to tower 1, we first move the substack 1 from tower 0 to tower 2. Since there is one element, we simply move that element from tower 0 to tower 2. Then we move 2 from tower 0 to tower 1. Now we can move substack 1 from tower 2 to tower 1 by moving disk 1 from tower 2 to tower 1. And we end up with this. The final state of the game is the following stack. All 3 disks are now in tower 2.